Today, we're diving straight into an explainer about a story that represents just a profoundly haunting philosophical clash. On one side of this, you have the Manhattan Project. It's an absolute triumph of human engineering, deterministic precision, and highly calculated intent. But on the other side, well, you have the chaotic, completely indifferent forces of nature. We're going to examine exactly how the most meticulously engineered machine in human history literally collided head-on with the unyielding mathematics of weather, geography, and pure chance. So think about it for a second. Is our universe deterministic? Meaning, is every single event just the inevitable consequence of every prior event, locked in this endless chain stretching all the way back to the dawn of time? Or is our reality fundamentally chaotic? Is it governed by variables so microscopically small and sensitive that they're practically impossible to predict? Now, usually this is just a fun thought experiment. But as we'll see in this explainer, on one very specific day in history, this question wasn't just theoretical. It was incredibly real. Because on the morning of August 9th, 1945, this equation right here became agonizingly real. The probability of survival for hundreds of thousands of people was quite literally a function of wind, smoke, cloud cover, and time. This wasn't some abstract mathematical model we're talking about. This exact equation directly governed the fate of entire cities. And to really understand why human lives were suddenly just variables in an atmospheric equation, we have to start with the incredibly rigid rules of the military operation itself. The United States Army Air Forces had this absolute, unbending, geometric constraint for the B-29 bomber known as Bockscar. The rule was visual targeting only. Radar drops, strictly forbidding. The crew actually had to physically see the target through the Norden bombsight. Now, this was an analog computer. Well, a highly sophisticated analog computer, really. It took in the aircraft's speed, its altitude, and drift to calculate the exact bomb release point. But here's the catch. It was entirely useless without a direct line of sight to the ground. The math behind this requirement was incredibly elegant, but man, was it unforgiving. See, at an altitude of 29,000 feet, when you drop a payload, it falls for exactly 43 seconds. And during that parabolic fall, the bomb travels forward nearly 2 miles. The Norden bombsight had to perfectly calculate the intersection of that falling arc with a specific coordinate on the Earth. So the absolute crucial point to remember here is this. Achieving that mathematical intersection required a clear sky. A strict rule made by men ultimately demanded total cooperation from the atmosphere. Section 1. The Fluid Dynamics Shield, a chaotic defense. Unbeknownst to anyone on the ground, the primary target, the city of Kokura, was actually being shielded by a chaotic mixture of weather and drifting smoke. You see, the day before, the nearby city of Yawata had been firebombed, and as Bockscar approached Kokura, the smoke from those burning fires was drifting northeast on the upper-level winds, and it was mixing with a completely natural convective morning cloud layer. The result? A 70% cloud obscurement right over the target. This was literally the Navier-Stokes equations, the complex math that governs fluid motion, playing out in real life to create an impenetrable atmospheric shield. So, over the course of 50 agonizing minutes, the crew made 3 separate bombing runs over Kokura. On the first pass, they had absolutely no visual, so they aborted. On the second pass, they saw some fleeting gaps in the clouds, but they couldn't secure a confident target lock. Again, they aborted. By the third pass, anti-aircraft flak was actually bursting around them, and the fluid dynamics of the smoke and clouds had only thickened. The bombardier literally needed just 20 seconds of continuous, clear sightline, just 20 seconds to fulfill the mission's mathematical constraints. But the chaotic atmosphere absolutely denied it. Section 2. The brutal fuel equation, the margin of error. Now here is where a single mechanical failure is about to rewrite history. Before they even took off, a faulty transfer pump meant that 600 gallons of fuel were totally trapped in a rear tank. The fuel was physically on the aircraft, right, but it was completely inaccessible to the engines. Bockscar had just spent 50 minutes circling Kokura, burning through combat-level fuel, and because they started off 600 gallons light to begin with, the aircraft was now rapidly approaching a critical threshold. Pilot Charles Sweeney was forced into this absolutely brutal calculus in real time. Just look at the options he had left. Option A was returning to Tinian, which was 1,600 miles away. Given their fuel state, that was a suicidal margin. They'd drop right into the Pacific. Okay, option B was diverting to Iwo Jima, about 700 miles away. That was technically possible, but it required jettisoning a live nuclear weapon into the ocean. So that leaves option C, a single pass over the secondary target, Nagasaki, just 95 miles away, before making an emergency run to Okinawa. The unyielding arithmetic of their fuel consumption basically funneled the entire mission down this single viable path.
Section 3. The 20-second window. A gap in the clouds. At 11 a.m., the crew arrives only to find Nagasaki just as clouded as Kokura was. By 11:01 a.m., with total obscurement continuing and their fuel practically gone, an ocean drop was completely imminent. They were quite literally seconds away from ending the mission in the East China Sea. But then, at exactly 11:02 a.m., a mathematical anomaly happened. A seam in the cloud cover, driven by the very same chaotic fluid dynamics that had just saved Kokura, miraculously opened up. It provided exactly the 20-second window the bombardier needed. But that fleeting gap in the clouds forced a really rushed release. The bombardier couldn't acquire the original primary aim point at all. Instead, he sighted on the Mitsubishi torpedo factory. This split-second visual compromise actually displaced the hypocenter of the blast by 2 full miles from the intended target. The bomb fell for its 43 seconds, and right behind it, the clouds immediately closed back up. Section 4. Topography of ruin, the final variable. Now, the bomb dropped on Nagasaki, codenamed Fat Man, was actually significantly more powerful than the one dropped on Hiroshima just 3 days earlier. Hiroshima's bomb was about 15 kilotons, Nagasaki's was 21 kilotons. That is roughly 40% more explosive energy. Simple arithmetic would tell you that a bomb with 40% more energy is going to cause correspondingly greater devastation, right? Well, arithmetic, as it turns out, is not geography. So Hiroshima was built on a flat river delta. That allowed the blast wave to propagate evenly outward in a massive circle, resulting in roughly 140,000 fatalities. Nagasaki, however, is situated in a steep, narrow valley, flanked by these huge 1,000-foot ridgelines. When the blast wave from the much more powerful bomb hit those valley walls, the energy was reflected, it was diffracted, and it was forced straight upward. Millions of years of ancient tectonic activity had essentially created a natural mathematical dampener.
80,000. By the end of 1945, the death toll in Nagasaki was approximately 80,000. Because the bomb was dropped 2 miles off target, and because it detonated inside a geographic bowl, those ridges ended up protecting large portions of the city. Human mercy played absolutely no role here. It was simply the indifferent shield of geology that prevented the rest of the city from being erased.
Section 5. Butterfly and bomb. Chaos and destiny.
So we're faced with this incredibly stark reality. 80,000 lost lives in Nagasaki, contrasted against the 212,000 people in Kokura who survived that day, purely because of a puff of wind and some drifting smoke. In 1972, a meteorologist named Edward Lorenz coined the butterfly effect with this exact kind of question. He proposed that in a highly complex, chaotic system, like the Earth's atmosphere, the smallest perturbation can amplify and completely change the outcome. On August 9, 1945, the smoke rising from a nearby fire was that butterfly's wing. It thickened the clouds over Kokura, just enough to exhaust a fuel supply, which narrowed a decision tree down to a single secondary target, where another completely random gap in the clouds opened just long enough to doom one city instead of another. Thousands of the absolute brightest minds on Earth spent years engineering a device of clinical perfection. I mean, it was a marvel of deterministic physics calibrated right down to the microsecond. And yet, once it left the runway, its destination and its terrifying impact were dictated entirely by the cold mathematics of chaos. Weather, mechanical friction, and ancient topography simply took the reins. Which leaves us with this final, provocative thought for our explainer today. When we look back at the terrifying fragility of our world, we really have to ask ourselves, are the most pivotal, history-altering moments actually determined by grand design and careful human intention? Or are we, despite all of our incredible technology, simply governed by the chaotic, indifferent forces of nature? Take some time to think about the invisible variables shaping our reality today. Thank you so much for joining me to explore this incredibly complex geometry of fate.